Hi, I'm Ara, N6ARA, and welcome to a quick update video on the TinyGawant Antenna series. Now, if you're not familiar with the TinyGawant, it's this small little QRP HF antenna system that I've been working on for about the past year. I documented my process on how I went from an idea all the way to a final product design in a 3-part YouTube series that I've linked to in the description below. So if you haven't watched that, definitely go check that out. Now, upon reflecting on that YouTube series, I realized I never actually covered how I manufacture these things and get them out into the world. So today what I want to do is peel back the curtain and show you how we're manufacturing them in-house and to address what is our biggest issue, and that is the demand is actually way higher than our supply. The manual way we are building these right now is simply not going to scale, and we need to figure out ways on improving that process. So I'm at least going to show you how we're doing it now, and I'm going to talk a little bit about future hardware that's coming to help us automate and optimize the way we build the TinyGawant. So with that said, let's dive in. All right, so in order to talk about manufacturing, I figured we'd start here. This is the kit of parts you receive when you purchase a TinyGawant, at least as of this recording. You then have to follow the manual on assembling and soldering all these components together to build up your TinyGawant antenna. I'm thinking about eventually making a fully assembled version of it available on the store, but at least for now, it arrives as a kit, and it's relatively easy to solder and build yourself, and it's quite fun in my opinion. So let's look at the components here. You have the antenna whip itself, the 3D printed enclosure, a bunch of large components that you either have to solder or bolt together with the main board, the TinyGawant board. And this board, as you'll notice, has all the surface mount components pre-populated on it. And that was actually a conscious decision. Originally, I thought about just including the surface mount components in the bag of parts, but realized that most folks may not have either the tools or the experience to put one of these together. And so I made it a requirement on myself to pre-populate these surface mount components with the board and provide that to all the customers. So what I'd like to do now is take a quick step back and talk about how each of these components are manufactured. Frankly, the more interesting one that I think is how this PCB is assembled in-house, and I will definitely be covering that more. In fact, that is the bottleneck of our entire manufacturing process for this product. However, I thought it was also worth covering how the enclosure and the bag of parts are assembled and put together. For the enclosure, we use a Bambu Lab X1 carbon to print them out of PETG. And the Bambu Lab X1 is just the workhorse of the company. It prints every single component that we put into our products, and it's just been reliable and consistent with quality, which I really appreciate. In fact, I'm thinking about upgrading to the H2D or H2C in the future so I can do manufacturing of components with color at scale. The X1 carbon can do multicolor, but it's a little bit wasteful and slow at it. So I might consider that in the future, but for now, that's kind of why you see everything as a monocolor 3D printed component in the kit. As for the bag of parts, aside from the 3D printed components, there's also the variable capacitor, and you get your connectors and toroid. I ended up including the hex wrenches that you need to assemble the enclosure together and install the capacitor. And you know, originally I thought, why include a tool? People probably have the tool, but the reality is not everybody has hex wrenches. I think, you know, a Phillips screwdriver, sure, but not everybody has the exact hex wrench you need. So I threw all the necessary tools for that into the kit. And aside from that, the wire that you need to, or the enamel wire that you need to wrap around the toroid is probably the most time-consuming part of this bag of parts. You literally have to, you know, pull it out of the reel, cut it, roll it up, and then, you know, put it in the bag. And while that sounds really simple, it doesn't scale very well. It's not easy. It's not, you know, picking up a part from a bin and throwing it in the bag. There's some extra effort involved. So that's probably the slowest part of putting this kit together, and is something I think my dad, who manufactures and builds all these kits, will be optimizing and improving upon in the future. He is always coming up with interesting jigs and stuff to speed up the assembly process. Okay, so let's talk about how this board is actually manufactured, because it's obviously the more complicated thing to put together, and there's many ways to go about producing it. You know, if I only had to make one, of course I could just put each component on there and hand solder each pad until all the parts are complete. But obviously that is like the worst way to scale up for production. Hand assembling each component just makes zero sense. So what I'm going to show you right now is how I was going to be doing it for at least maybe 50 to 100 boards. And that method, this method I'm about to show you, works okay for that, but there's a certain point where it just becomes too time consuming if you're trying to make a lot of them. And in order to make a lot of them, you need some machinery and automation, the same way mass manufactured electronics nowadays are made, using a pick and place machine. So I'll talk a little bit about that as well. Focusing on the board assembly itself, this is how the board arrives from the manufacturer after I send the files out for fabrication. And as you can see, it's all the board is already pre-cut and the edges are deburred. And in fact, you can't see this, but I do ask the manufacturer to do e-testing. So each of these electronic pads here are tested for continuity against other ones to make sure that, you know, nothing got mismanufactured, or if there was a defect in one of the boards, I wouldn't end up getting a defective board and having to populate it, and it turns out, you know, it doesn't work. So that's usually well worth the price in my opinion, especially if it costs a lot to get your boards replaced for a customer reporting issues. Now the next step here is to take this board and to start placing all the components on it, at least the surface mount components. And I could grab these surface mount components out of the bag, take each one out and start placing it on here and using solder wire to solder it by hand. But again, that is just going to take way too long to do. It's great if you're doing one or two, you know, boards or building a kit, but definitely not scalable whatsoever. And so the next best thing after that is actually to use a combination of solder paste. So this is, rather than solder wire, it's actually a paste that's comprised of a bunch of super tiny solder balls suspended in a flux. And there's different mixtures and stuff, but this one is a lead-free paste that we use. And you could put a needle on the end of this, and in fact you could, you know, inject little solder blobs where the pads are for the components you want to put on there. But the easier way to do this, especially at a slightly larger scale, is to use a stencil. So this is a custom laser cut stencil by Osh Stencils that has all the cutouts of the pads that need solder for this assembly. So I custom chose which pads to expose and not expose for this, and then got this laser cut. And then all I need to do is align this with the board, right? And if you kind of, usually you put this in a jig so the board doesn't move around, but at least for the demo here on film, I'll always show you that you can kind of, you know, you can see you have to like line it up just right, press it down, then, you know, place this tape down here. And now all of the board is essentially masked off except the pads that I want to put the solder paste on. And so I could take the solder paste, you know, squirt out a bunch of solder paste here, and then use a credit card or just a card or some sort of squeegee to drag across that paste, lift it up, and now all the pads that need solder have solder on them, or at least solder paste on them. And then I can take each of these components and manually place them on the board. And so now it's like, well, how do you solder that, right? Well, the next step is you put that inside an oven, and that oven then heats up, and it's a special oven, by the way. That heats up and melts all the solder on the pads and the components all at the same time, simultaneously. And the nice thing is, you know, pretty much you could build like a couple of these. Like right now I can fit about 15 boards inside the oven that I have, and you end up soldering 15 boards all at the same time. Now, this technique works well, but the slowest part of it, I found at least, is having to peel back the tape, fill with all the components, use tweezers to drop it on the board, and it takes a while. Again, you could do it for, you know, tens of boards, maybe 100 boards or so, but it gets really, really tedious having to deal with these reels. And so what I decided to do, and I actually bought this a while back in anticipation, is use something called a pixel pump. Now you may be asking, what is a pixel pump? And well, it's this thing right here. It's a open source manual pick and place machine for people doing, I would say, medium volume builds. It's made by Robbins Tools, and this is the very first generation of the machine. I believe he has a new one coming out fairly soon, the Pixel Pump 2. I bought this a little while back, but it was kind of nice to dust it off and be able to use it finally for a good reason. Essentially what's inside here is a vacuum pump that's operated by a foot pedal that's down below. So it's off screen here, off camera, but essentially if I push this pedal down here, it turns on a motor inside the pixel pump and generates a vacuum that runs through this tube to this hand tool that has a tiny little needle on the other end. And this allows me to pick up the parts from the reel directly and just drop them on the board and then release the foot pedal to, turn off the vacuum, and then the part stays on the board and I can go pick up the next part. And so this kind of seems a little gimmicky at first, but for doing medium volume builds, this really does speed up the process versus having to use little tweezers and pick up parts, and there's not always enough clearance for you to even pick up the part from the reel using tweezers. Now what I haven't explained yet is what this contraption is. This is actually a manual part feeder, and these are little cassettes that hold all your components. Here I've labeled R1 to, it's R1, R2, and R4. I just ran out of space. And what you can do is you could take your components and load them up into this feeder and then place them on this little weighted holder. And now all the components that you want to pick up are available just in a nice row, and that really, speeds up the process of having to pick up a reel, grab the parts, put it down, put the reel away, grab the next part. You get the picture. So all I have to do now is start by peeling back this tape here to expose all the parts. And there's even a little cavity down below, right under this, to hold on to the tape that's holding it in place or keeping all the parts inside the reel. And you can slowly pull that tab out and it'll feed out all the parts. So what's cool now is I can pick up one of these parts fairly quickly, right? So if I press down on the pedal, pick up the part, and now I have the part, and I can just drop that part on the board, let go of the vacuum, and there you go. The part's on the board. Well, okay, it's on the table, but that's for a demo, right? Conversely, I can also pick it up and put it back in the reel. Now, one thing I learned while actually using this system is that the reels are actually kind of susceptible to kind of doing this diving board problem where you go to pick up a part, you let go, and a bunch of parts go flying off the reel. And at first I'm like, there's no way this is the final product. I must be using it wrong. But every demo video I looked at only had just a little bit of the tape sticking out. And if you continue using this, and you can imagine this like reel comes out as you keep pulling more components out, this becomes kind of like a bump hazard. As you bring your hand nearby, you might accidentally strike the tape and a bunch of components will go flying out. And this became problematic enough where I actually decided to 3D print my own little holder to slide the reel into, because I kept bumping the thing and suddenly losing a bunch of parts, and that cost money. So this is not something that the Pixel Pump comes with, and in fact I'm sort of just experimenting with this design. But essentially this little holder here lets you line up all your components and sort of stabilize them to some extent. And it effectively offers a nice flat surface for you to come in and pick up your parts. So much easier. And you have at least, I would say, typically like 10 parts available to you at a time. And then you can keep pulling on this tab to feed out more and more parts. And I gotta say, 3D printing this little table here was probably the best decision I made with this whole setup, because it's made picking up the parts so much easier and so much more consistent. I'm kind of a clumsy person. I do tend to hit this setup as I'm moving the hand around, and as you get bored, you want to try to go faster and faster, and of course that leads you to making more errors. Yeah, printing this thing, taping it down so that it's nice and rigid, made a world of difference, and it's just sped up the whole process of picking up parts and placing them. So I'm quite happy with that. All right, now that I've shown you a rough outline of how all the components come together and get placed on the board, I think what I should do now is load this up and actually show a full assembly of one board, and then we'll take it over to the oven, and I can kind of walk through how the reflow process and filtration system works. So let's dive into that. All right, got them all loaded into the reels. Next thing to do is start peeling back the tape and running them through this little component table. Just got to do this really carefully. Has to be the single worst part of loading it up. One wrong move and parts go flying everywhere. Oh, there you go. Wow. This is really annoying to deal with. And by the way, this is also why when you order components, you account for some percentage of attrition. You know that you're going to lose some components to the floor. Maybe the machine's not going to pick it up, or I'm going to miss. And you know, in this case, I am the machine, and I might miss a part or drop a part, and it might fall on the floor, and I'm not going to use that if I can't find it. So you do actually have to account for losing some parts during an assembly. So don't buy the exact amount you need, buy a little over. Okay, so I admittedly had to stop recording and fix all the components that had popped out. I picked them up off the table here. Thankfully, they didn't stray far, and put them back in there in the reels. I also found that if I brought the reel holder, these feeders, closer to the 3D printed table, that it's less prone to bouncing as I'm pulling the reels out and pulling the tape out. You know, this works. It wasn't pretty, and frankly, as with any manufacturing process, the start is always the pain, and this is no different. I've got it set up now. I think what I'm going to do next is go over to the solder paste station and show you how I get the solder paste set up, and then we'll come over here and pick the parts and place them on there. So here's the solder paste station. Essentially, Oshkosh, when you purchase from them, will send you these nice little right angle brackets for you to align and set up your board in. So I've taped them to the sides. I know this is sitting on cardboard. It's definitely not the flattest surface, but it does kind of keep the contamination of all the solder paste at bay, and it works just fine. So all I need to do is place the bare PCB without anything, no components, no solder paste on it, of course, and then align the mask or the stencil, and that, once I get it kind of dialed in, make sure the clocking is right. Both, you actually need to line up both translation and rotation, and kind of press down on it to feel like you're sure that it all looks good. Once that looks good, just tape up the top side, and then now I can paste, drop some solder paste on here, drag it across, peel it back, and then start placing the components on. Okay, to start, you get the solder paste, open that up. I usually like to drag a little bit across here. Next, you take the card that it comes with for spreading the solder paste, so a nicely labeled solder paste spreader. And just like, t-shirt silk screening, you drag across the paste. All that solder paste that was on here that was designated for those pads made it through to the other side, and the rest of it kind of sticks up on top of the plate, and you can clean that up later and reuse that paste. So now when I lift the solder stencil, magically all the pads have solder paste on them. With the solder paste all set, now all we need to do is pick up the parts off the reels, place them on the board, and we should be ready for the oven. Well, this is a bigger part, struggling. This one I usually will like do the last mile. There we go. Okay. The switch is a little bit heavy, and frankly, there are different nozzle sizes. I don't want to have to keep switching out this, this needle nozzle size for something that could handle the bigger part. So usually it's fine. Sometimes it struggles a little more, but other times I'll just use the tweezers to pick up the switches at the end. So that's a demo of how I pick up the parts from the reels and place them on the board. The next step is to actually take this board out and to place it in the oven to melt all the solder. Now I'll bring this board up close before we reflow it, just to show you what it sort of looks like before the solder is melted. The components tend to stay where they're placed, but you do have to be careful. If you tip the board a little bit too much, components could move or fall off the board. So it's best to keep it level, and what I usually do is I pick it up from the stencil holder here and place it on the plate that goes inside the oven. And you just have to be really, really delicate, especially when you've got like 15 of these boards sitting on a plate. If you drop that board, you've lost like an hour of work. So this looks really good to me. For the purposes of this video, I'm just going to demo what one board reflow looks like. But yeah, again, typically it's more than, I would say I can fit about 15 to 17 boards on a single plate before it goes in the oven. All right, so let's go reflow this and talk a little bit about the challenges there. Now, to reflow the board, I use a reflow oven and a fume extractor. And if you're wondering, is that really a Black & Decker toaster oven? The answer is yes, except it's a little special. Inside, there's a heating element that's been added along with a bunch of other sensors and some reflective tape to heat up the inside. And internally, none of these switches and buttons work anymore. It's all controlled by this controller here called the Controlio 3. It's this wonderful kit that you can purchase. You can also buy it as a fully assembled unit. But as a kit, you put this thing together. You have to glue a bunch of stuff and do a lot of work. And it does take quite a while to modify this toaster oven. But once you have it modified, you can actually run solder profiles on it. And it will actually properly follow the correct profile to preheat your boards and then run it through the correct ramping so that the solder paste melts correctly and you get really good, consistent reflow. Now, one issue with running something like this is that it actually generates some pretty awful fumes. Most of it is just the flux burning off. And so I've paired it with a fume extractor to pull up and extract out all the smoke and odor that comes out of this reflow process. And in fact, the little funnel that this thing came with was a little too small, so I ended up 3D printing my own little double nozzle to pick up the fumes as much as possible. And interestingly enough, I actually just got this fume extractor the other day. Up until now, I was using one of these cheap $75 fume extractors off Amazon, but what I noticed was the fumes coming out were getting captured by it, but the whole room started to smell pretty bad. In fact, I keep the doors open here. You're supposed to ventilate really well when running one of these. And ideally and fairly soon, I would like to actually take the output of the fume extractor and run it out to the roof. But for now, I was actually using this guy, and the interesting thing was the odor was all over the place. I mean, it did nothing for odor. And it wasn't until I opened it up that I realized inside was just a very, very porous filter here. And that's it. That's the whole setup. I mean, you can see right through it. So obviously it's not going to stop any odors from not getting out. So this thing was kind of, I guess it's kind of useful if you want to just suck up the solder fumes if you're soldering something, but it is not very good for an application like this. I ended up finding this fume clear and discovered that it's actually a HEPA filter and a carbon filter all in one. So at least the HEPA filter will capture all the big and smallish particles, and the carbon filter will at least extract out all the odor, and in theory, the place shouldn't smell so bad when running this. But again, I do want to take the output of this fume extractor and pipe it out of here, because really, this is not something you want to be doing indoors without proper ventilation and fume extraction. Anyway, enough chit-chat. Let's get the board on here and let's run it through a solder profile. All right, so here's the board we populated earlier. Again, I would probably put way more of the boards on here, but for this demo, I figured I'd just reflow one of them and just show you the process. So this would go inside the oven. Whoop, missed the rail, there we go. Close it up. Then to run the reflow profile, I click Profiles. My first profile that I have loaded on here is the lead-free solder paste that goes up to 250 degrees Celsius. And you can see right now it's actually it's quite cold in this workshop. It's about 16 Celsius. But once I hit Run Profile, this will track the internal temperature of the oven and properly ramp it up and reflow it. So normally, this oven actually draws quite a lot of current, so I have to go through a process on my end in the workshop, going around and turning off a bunch of things so I don't trip the breaker. Hopefully this isn't going to be too problematic. I haven't run it yet with the fume extractor, so I guess we get to find out together if we trip a circuit breaker today or not. All right, first we're going to turn on the fume extractor, set it to max, then hit Run Profile. Ooh, you can actually hear the fan changing speed as the oven starts to draw power. All right, now that the oven is done pre-soaking to 75C, it's headed up to 150 degrees Celsius. There's our little board. I don't have a nice enough camera to actually capture a cool reflow, so you're gonna have to settle with this bad iPhone video. Woo! It's really heating up in there. All right, we're at peak power and peak temperature. And now what you can see is this little servo here is slowly opening it up to begin the cool down phase. And the fume extractor is actually doing a fantastic job right now, grabbing all those fumes and filtering them out. I don't smell anything actually. This is really great. And for the record, I do have the doors open and ventilating the room, so this is totally fine. But this fume extractor has made it so much better. Now, once the reflow is done, you can actually get a cool profile of how much it heated up and where it plateaued, peaked, and then cooled down. That's really useful in case something does go wrong during the reflow process. You could see that in the data. All right, all done here. Time to take a look at the board. Nice. It's still a little hot, so I'm going to use these pliers to bring it out. But it's looking really good. I can tell from over here. We'll get a closer view once it's had time to cool down. And here it is. All these solder joints look perfect. And usually what I do at this stage is I'll just do a quick inspection, ensure that all the parts are still on there. And I also look for if any of the parts have tombstoned. What can happen is sometimes if the solder paste isn't applied correctly and evenly, the surface tension will pull one of the components and lift it, and it ends up kind of looking like a tombstone and doesn't make proper contact with the other side. So obviously these look nice and flat, but that's always something to look out for when you run a reflow. So yeah, this board looks ready to go. It's passed my eyeball test, and that's it. This board's ready to ship. So after watching that video, you could probably see why I want to automate and optimize the process of building these boards in-house. Hand building them is just not going to scale at all. After thinking about this problem a little bit, I realized the only way forward is to purchase a pick-and-place machine. Now, if you're not familiar with what a pick-and-place machine is, it's essentially a machine that picks and places the components for a PCB. Really well named, right? These machines can range anywhere from a few $1,000s to hundreds of thousands of dollars, if not millions. However, the sort of category and frankly budget I have is in the couple $1,000 range. So the next question is, which pick-and-place machine to buy? And I ended up doing a lot of research on this subject and compared a lot of options, but realized that there's only a few of them that I could realistically pick from. However, one candidate stuck out amongst the rest, and that was the Lumen P&P. This pick-and-place machine is made by a company called Opulo, and they're based here in the United States and have done a fantastic job not only open sourcing their product, but also supporting it. They have a wonderful Discord channel where you have a huge community of people not only supporting others building and setting up their machines, but also modifying them. And the best part is this machine actually exceeds the capabilities of what I need right now. So that means future products and more complex products can be made without having to retool my entire pick-and-place system. Now I promised myself if we sold out of all of the TinyGawants in the first production run that I would end up buying this pick-and-place machine. And today I'm happy to report that we did. Yay! I genuinely did not expect such a large support and interest in the TinyGawant, and I'm just so grateful for this audience and for all the people who have been talking about it and helping spread the word. Because of you, I was able to purchase one. It's going to be arriving in the next few weeks. I bought it about 2 weeks ago, and it's a 4-week lead time, but there's going to be this odd period where I'm manually continuing to build the TinyGawants while the new pick-and-place machine arrives, and I got to spend about a couple weeks setting it up and first building it, getting the software going, calibrating it, and then tooling it to build the TinyGawant. That shouldn't take too long, I hope. I might even try to document that process because it is guaranteed to be chaos. Anyway, I'm super stoked for it to come in. I can't wait to share what that experience is going to be like and hopefully give you an update video on how these are being built in-house quickly. With that said, thank you so much for watching. Please like and subscribe. Share this with someone you might know who might find it interesting. And I'll see you next time. 7-3. And that's a wrap. That's a wrap.